Hello everyone and welcome to Unacademy classes. My name is Abhishek Mishra and I am teaching you manufacturing for GATE examination. And in this class, I will be continuing my questions that I was doing in my previous class, and the questions will be important with respect to GATE examination. So in this important question series, what we will be doing is we will be looking into important questions from the manufacturing subject which can come in your GATE examination, or which can just make your concept strong, or we can simply discuss some tips and tricks in such questions. So we will be concerning our main focus on these questions. So now without further ado, let's start this class. But before doing that, first of all, I would like to discuss about me. So I've secured All India rank 662 in GATE 2020, that is this year's GATE examination. I've completed my MTech in 2019 from IIT BHU Varanasi, and I have good teaching experience of 2 years in mechanical engineering subjects. Some of my interests are photo editing, video editing, cricket, football, and all sorts of games. So that's it about me, and I will be teaching this class entirely in English. And the English will be very simple because mainly we will be discussing about the terms, the words which are there in your manufacturing subject, because these terms are technical. Therefore, I think you would not be having that much difficulty in understanding this discussion. And Unacademy's app, you should just download it. As you can see in the screen, the Unacademy's app is very well made and it is free of cost. So if it is free of cost, then there is no harm for you to check it out and just go to your respective app store, check out the app after downloading it, and just see for yourself if this app is helping you or not. If it is helping you in your preparation, then it is very good. You should take advantage of it, and you should just take advantage of benefit of every tool available, every thing available for you to be better prepared. So again, this app, you can see in the screen upcoming classes, recorded archive classes, upcoming test series, the test series that you can give on the go, and structured courses, performance analysis. All thing is here listed, here shown properly in the Unacademy's app. It is free and it is complete experience, complete package if you want to prepare GATE online. And Unacademy is offering all these benefits if you subscribe to Unacademy. Unacademy subscription, just like any other institution or any other coaching, you pay fee. Here also you will need to pay a fee, but the benefits you are getting are enormous and the fee you will be paying is very affordable. And this much benefits you are getting for the prices that I will be showing you in the upcoming slide. You can see that the benefits are very high quality benefits and very crucial benefits. For example, daily live classes. Since the live classes will be held daily, therefore you can just prepare in a way that you can maintain your rhythm, because live classes, if you attend daily, then you will be getting in touch, you will be staying in your mindset will be clear that you have to prepare day in day out, which is very much needed for GATE preparation. And this daily live classes is important because here you can interact with the educator, and also you can discuss with the other students which are there in the chat. So overall, this interaction that Unacademy is offering here on YouTube, we can see the interaction is very limited. We can interact only in certain way, but Unacademy's website or their app offers a lot of quality interaction, like live quizzes. Teacher can ask you live quizzes during their class after discussing a topic, so you have to be focused during the discussion, and after the discussion of the topic you can just answer this along with the other students. So there, since the answering will be done with you have to compete with other students to give the answer first, because that's the thing about GATE examination. You have to solve questions quickly. Therefore, you will be prepared in a crunch situation. You will get practice of doing question in such situation where you have to solve them fast. So this is very important and very crucial, and Unacademy's daily life classes or Unacademy live classes will offer you or is offering you this. And there are test series also. So again, this is one of the most important things that I would like to just discuss here, that test series is very very important for you to give, because test series makes or breaks your gate score. Since you are preparing all these subjects, all this lengthy topics you are preparing, but how you are implementing this, how you are using this in a crunch situation or in a situation where you have to solve multiple subject questions is the key. And to see that, to check out your performance in that situation, you have to give test series. And in test series you will make mistake, and from that mistake you have to learn, because it is better to make mistakes in your preparation practice than to make them in your gate examination. And a lot of mistakes that you will be making will be very silly, will be will be mistakes that you cannot imagine you can make. But the test series situation is like that, the test situation is like that, that you could make it, you can make it. And therefore you have to practice to avoid such mistakes, and live test series are there for you to do that. Also you will get your performance analyzed by the Unacademy's team, and after the analysis of your performance you can just see which areas you need working upon. And one more thing that you can see is that structured courses are there in Unacademy's website. Unlike YouTube where the courses are scattered, you are getting all this in a YouTube channel of Unacademy or any other YouTube channel. You are mainly getting courses in a manner that is not well organized. But structured courses are meant by that you are getting textbook. In textbook there is table of content, there are topics and subtopics which are properly arranged, and they are arranged in such a manner that you get a progressive study, means you get step by step information about the subjects. Unacademy is also making sure that structured courses are there for you to get benefit from. Therefore it is very very important for you to study from Unacademy's website to take advantage of this structured courses thing. And unlimited access of content will be there, means if you are subscribing today, then you will be getting all the content that has been held previously. And all this content you have to just select and you have to just start studying from. So there is no limit of the content that you are getting. You just have to select the educator, select the subject, and start your preparation, start giving test series. So subscribe to Unacademy, and the educators that are teaching in Unacademy are very well qualified. They will share a lot of their experience for you to study in an effective and efficient way. And there are multiple educators of a single subject, so there is also option for you to choose from educators. If you want to study from a different educators or a particular subjects, you are free to do that. And here is the price of Unacademy that you can see, and the prices shown here are very affordable if you are comparing them with the traditional offline classes. So traditional offline classes prices, if you are comparing, then these are very affordable, because mainly you can see these three prices that I am just highlighting here: 12 months, 18 months and 24 months. In this prices, in this packages, you are getting a heavy discount of 54 to 67%. And you can see that the per month price of these packages are very much worth it, because you will be getting all the content that I have discussed. And in that content there is test series also, which is easily costing thousands of rupees. And in Unacademy subscription plan, the test series will be updated regularly, so you will have benefit of always getting new in Unacademy subscription. And if you want to save more money, then use this code that is listed on top of your screen, that is ABHIMI, to get flat discount of 10% over this already discounted price. So the new discounted price after you have applied the code will be this. So this is the discounted subscription price, which is so this is the discounted subscription price which is there when you have used this code, that is ABHIMI, to get 10% off. So again, Abhi, MI for Mishra, ABHI, Abhishek. So if you are preparing for GATE 21, then you should go for 12 months plan also, because in your GATE 21, after that you have to give some other examination, other PSU examination, or you have to give for prepare for interviews, or you have to generally study for the your MTech admissions. So all these things you have to plan. You can plan from now only, that can just subscribe to 12 months package and just prepare using that discounted price package. Because if you are selecting 1, 3 or 6 months, then you maybe there time comes then that you can need 3 or 4 months more subscription. Then you have to pay more money, because of this 1 or 3 month subscription price value greater than or you are not getting that much discount in the first two packages, mainly the first 1 month package. Therefore 12, 18 and 24 months are the things that you can just see and subscribe. Just visit their website, Unacademy's website, and see for yourself, and don't forget to use this code, because you can save a lot of money. I am telling you this again and again, because if you don't use this code, you can easily just give this much 10% off that you are getting discount. You will be not be getting that. So this that will be not be a ideal situation. So just use this code. And the discussion that I was having about the subscription prices was for the plus subscription price. So plus subscription was basically the classroom subscription, where you were studying along with the other students, and Iconic is personal coaching, personal test series, and all this you will be getting. So Iconic are for those who need one-on-one personalized experience, personalized teaching, and therefore these are the subscription prices. And again, 10% off if you want, then 12 months and 24 months after using this code. This prices, discounted prices, are shown here. So again, you can see since this is personal teaching that you will be getting in Iconic, these prices are still very affordable, because nowhere you can get this much of content, this much of benefits, this much of features in this money in one-on-one personal teaching. So if you need this, then just go for it and just prepare, because you are spending time, and if you are spending time, then just give it all, so that after your preparation you are very well satisfied, and so that you can go in your GATE examination by holding your head high, that you have prepared your level best. And therefore you have to just use all the tools that are available and just subscribe to Unacademy, so that you can prepare in a better way. And these are the final discussion about Unacademy final screen. Here you can see Plus and Iconic subscription benefits and the code which you can use to get 10% off. Subscribe today and just start giving test series. Give test series regularly and just see what mistakes you are making and work on that mistakes and work on your speed, because it is better if you can if you are making mistakes now, then you are making mistakes in your GATE examination. So work on your performance by giving test series and just study, give your level best, and just prepared in such a manner that you are satisfied at the end of your preparation. So now we will be doing questions, and our first question again in this class I will be doing manufacturing questions which are important for GATE examination. The first question that we will be doing is this question. In this question is from the tolerance topic. So size of a hole to be checked is given as 25 plus minus 0.02 mm. So we will just solve this question now in a relaxing tone, in a tone that we will be discussing all the things. So let's just do this. So the first line, the only line that is there in the question starting is size of a hole to be checked is given. So the hole size is to be checked, therefore which type of gauge we are using, first of all we will be discussing this. So let's write, like I am writing is here. Therefore to check size of a hole, we use plug gauge. So it might get asked in GATE, or I think some of this type of question has already been asked. Which type of gauge is used to check hole or shaft? So for hole we use plug gauge. So remember the term, remember the name, plug gauge. It is the gauge which we use, it is the tool which we use to check the size of a hole. And the first thing that is asked to us is that upper limit of hole, what it is equal to. So this 25 that is given, the size of hole that is 25 given, this 25, first of all, this is the basic size. And this plus minus 0.02 mm are the variations, are the tolerance that we have to take into account. So upper limit will be the maximum or the largest size of this hole, and it will be 25.02 mm, and the lower limit will simply be the smallest size, which is 24.98 millimeters. Work tolerance, or simply tolerance, is the difference between upper limit and lower limit. So we will be writing this like upper limit minus lower limit. So it will come out again very simple, 0.04 millimeters. What is gauge tolerance? So gauge tolerance is 10% of So here what is gauge tolerance? It is 10% of work tolerance, and gauge, the plug gauge which we are using to check the hole size, it is also having a tolerance, and that tolerance value is equal to 10% of the tolerance of the hole whose checking is being done. Okay, so the 10% of work tolerance here is coming out to be 0.004 mm. So that is the gauge tolerance, and this wear tolerance, or here it should be wear allowance. So let me just write it like this, wear. So in this question where you are getting a plug gauge, or you are getting size of hole checked, so there will be a term called wear allowance, which is equal to 5% of work tolerance, and this is coming out as 0.002 mm. And you can see the 0.02 mm is even smaller than the gauge tolerance, because wear allowance is only added to go plug gauge. So since we are checking the size of hole from plug gauge, it is very simple, just follow me. Plug gauge is used to check the size of hole, and there are two types of plug gauge. First is go plug gauge, the other one is not go plug gauge. So go plug gauge is having the size equal to the lower limit of hole, and the not go plug gauge is having the size equal to the upper limit of hole. So dimensions of go plug gauge is simply 24.98, and here it is the 25, not 24, it is equal to 25.02. But since we are given wear allowance also, which is 5% of work tolerance, and it is added with the go plug gauge, therefore the dimension of go plug gauge will be 24.982, because of the this wear allowance that we have to add. Therefore this is the dimension of go plug gauge and not go plug gauge dimension will simply become this. And then we will write allowance. Allowance will be, let me just change the color of the pen. So since the dimensions of go plug gauge will be minimum 24.98, therefore we will be taking and here gauge tolerance is 0.004, so just simply write it down like this. So this is the size of go plug gauge and not go plug gauge. Upper size will be simply this, and for lower we will just subtract minus 0.004 will be minus, or you can have the limits as this. So what we did in this question is we first of all find very easily upper limit and lower limit. Then you have to remember the tolerance is simply the difference between the upper and lower limits, and gauge tolerance is 10% of world tolerance. So we calculated it. And why we calculated it? Because first of all it is asked. Second of all, we have to calculate dimensions of go plug and not go plug gauge. So for when we are calculating the dimensions, we need that gauge tolerance value, and also go plug gauge needs wear allowance added, and wear allowance is added in the opposite direction of wear, and the opposite direction of wear will be this, so that after wear the size will be what we desire. Therefore we have to add 24.98 this wear allowance in that value, and after that we are getting 24.982, and in that we are just putting the value of the gauge tolerance to get our final answer. So in this question you can see the objective, main objective to do this question, main objective due to which I discussed this question is because in this question there are a lot of things we have learned, we have discussed. We have studied about which type of gauge is used to check the size of a hole, how to calculate the tolerance, how to calculate gauge tolerance, in which type of gauge tolerance wear allowance is added, what is wear allowance, in which type of gauge is wear allowance not added, and how we are implementing, how we are using the gauge tolerance to find the dimension of a go plug gauge or not go plug gauge. So all this discussion we can have here, we had here, will, I hope this have made your concept strong, and I hope if any of this question, any of this thing is asked in your exam, then you can solve it. And as you can see in GATE examination, not all of this can be asked, or not all of this is usually asked. You can be asked simply one or two things, and I think you can just do it in a very quick manner because of the easiness, or because of the clearness of the topic that we have discussed. And now we will do our next question, which is, so I think I have discussed this question in one of my previous or my last class only, and somehow I have written this question again. So let's discuss it. Let's just see. I will just discuss it in a very quick way, very quick manner. So quickly, the thing here is drilling time is asked. So just see the question. In this question, the diameter of hole is given which is to be drilled. Thickness of a steel block is given inside which we are making the hole, and rotational speed feed is given, and drilling time is asked. But the main important thing due to which this question is listed, or this question is being discussed by me with you in this class, is this line. It is this line. So in this line you can see the required approach and overrun of the drill together is given as equal to the radius of the drill. So overrun, or I should write approach first. So approach plus overrun is equal to radius of the drill. So the thing that I have written here is I have written their sum equal to radius, not individually they are equal to radius. So if you are taking them r and r, then they will become 2r, and this whole point will be wrong, because in the question it is given the word that I want to focus here, I want to highlight here is together. So together they are equal to radius of the drill, and therefore their sum should be equal to the radius, not individually. When you have to take individual value of them equal to r, when it is given that the required approach and overrun both are equal to the radius. So both if are equal to radius, then you have to take individually them equal to radius, and their sum will become 2r. And in this equation you will not find x, which is the you will not find the x approach because of the approach already given. Therefore we will simply say, let me write it again, approach plus overrun is equal to radius, and the machining time will be effective length divided by feed into rotational speed square. So simply thickness plus radius of drill is 10, and we will divide it by 0.1 into 400. So we will be getting this answer in minutes, so it will become 50 by 40. So it is coming out as 1.25 minutes. So this is the answer, and in this question the main motive, the main objective for me to make you do this question was simply that the together term which is given for the required approach and overrun is making their sum equal to radius, not individually they are equal to radius. So together they are equal to radius. If it is given both of them equal to radius, then you will take their individual values equal to r and their sum equal to 2r. Now in our third question for the day, we are given this question from the topic orthogonal turning. So in orthogonal turning of a cylindrical tube of wall thickness 5 mm, the axial and tangential cutting forces were measured as 1259 newtons and 1601 newtons respectively. The measured chip thickness after machining was found to be 0.3 mm. The rake angle was 10 degrees and the axial feed was 100 mm per minute. The rotational speed of spindle 1000 rpm, assuming material to be perfectly plastic and merchant's first solution, the shear strength of the material is closest to. So in this assumption, since this is official questions of GATE, so you have to take the assumption discussion or assumptions very properly, very carefully. You have to see this, and here it is assumed that the material is plastic, perfectly plastic. So in your machining you have to just remember that you are assuming that your material is perfectly plastic, and you can assume merchant's first solution, that is merchant's theory, but you can only use this theory, as I have discussed in my class, use this merchant's theory only when merchant equation, only when all the other doors are closed, all the other things, all the other ways are not suitable or not, you are able to find the values of shear angle, rake angle or friction angle, then you can use this. Only then you have to use this. Don't use this from the get-go, because if you are using from the get-go the merchant's theory, then you will be getting wrong answer, because your values first of all are needed to satisfy the geometry. Therefore, find the values from the geometry itself. So in this question, what we will be doing is we have to find the shear strength of the material. So let us do this question in one of the other apps where I will be drawing the merchant circle also, which we will be needing to do this question, I think. So let's open this app and do this question. So we will first write what is given. So it is given that first of all orthogonal turning. So orthogonal turning we will write. We are writing all the relevant data that we require. So first orthogonal turning is given first, and the datas which are given are like this. The axial and tangential cutting forces were measured as, so we are given with axial cutting fx and fz tangential. So for orthogonal turning, first we will write what the values are. So the values that are given here are 1259 and 1601 respectively. And for orthogonal turning, the axial cutting force is Ft and the tangential cutting force is Fc. So you can relate them equal to Fx is equal to Ft and Fz is equal to Fc in orthogonal turning. And now we can see that our merchant circle, we will have this two values there, Ft and Fc, which we can use to just calculate other terms. So what other data here are given, that chip thickness after machining was found to be, so the cut chip thickness is given as 0.3 mm and rake angle 10 degrees and feed is 100 mm per minute. So the cut chip thickness is 0.3 mm, rake angle alpha is given as 10 degrees, and the axial feed always has the unit So this is the axial feed, which is usually equal to Fn. So Fn is given as 100 mm per minute, and the rotational speed is given as 1000 rpm, and that's it. We have to find the shear strength. So in orthogonal turning, since the question is of orthogonal turning, so just remember this, that in orthogonal turning, feed F is equal to T, which is the uncut chip thickness. And why we require the uncut chip thickness? Because we have to find phi. And why we have to find phi? Because we need to calculate the value of shear force, and after calculating this value of shear force, we have to divide them with the shear area to get the answer. Because what we have to finally calculate, let me just write by changing the color of the pen here. So to find shear strength, which is equal to shear force divided by the shear area, which is simply width into the thickness divided by sine phi. So here phi is needed, and to calculate phi we will be using this this equation tan phi, and this equation is very important, so you have to remember this equation. This is one of the most important equation in all of GATE examination, and here we have the value of phi with us, not phi, we have the value of alpha, that is the rake angle, and we can calculate r here, and after that we can calculate phi. So what is r? R is the chip thickness ratio, or it is the cutting ratio. So chip cutting ratio or chip thickness ratio. So R is equal to, this ratio is equal to chip thickness ratio, the T by TC, that is uncut chip thickness divided by the chip thickness. So chip thickness is given in the question, and the uncut chip thickness we can make it equal to the F, because in orthogonal turning this is the relation that is being followed. The F, that is the feed, is equal to the uncut chip thickness. From that we can just find out the values. So it is 0.3, and we are not being provided directly with the value of F, that is feed, but we are given the value of Fn and N. So axial feed is always equal to this Fn. So just remember, you don't need to just you don't need to do something new or learn something new other than that Fn is equal to the axial feed, and this Fn, from this you can calculate feed if it is not given. So feed will come out to be 0.1, which will be the value of uncut chip thickness in this orthogonal turning questions. So here R will come out to be simply 0.33. So R will be 0.33, and from this R we can calculate the phi. So phi will come out as 0.33 cos 10 divided by 1 minus 0.33 sine 10. So our phi is coming out as 19.02 degrees. So this phi we can use to find the shear strength, but before we can put this value here, we have the width, we have the here also one more thing, you have to calculate Fs, which is the shear force. So to calculate Fs you have to use the merchant circle, or you can use the pre-defined, pre-made formula that you can study, but I do not recommend to remember that, because that will ultimately make your whole this learning of machining more cumbersome, because you have to just be very precise in your remembrance of the formula. So just remember that what is the merchant circle and use this to just get your required equation. So this is your So right now I am drawing the merchant circle, and I am drawing the merchant circle in roughly that you should draw. And here you can see we have this first, I have drawn frictional force, and 90° we will be getting N, and we will be just joining this to get resultant. So here it is cutting force, thrust force. And finally we will be having another pair of forces. So this is the force that we have to just concern for this question. This is Fs, shear force, and this is Fn, the force that is normal to the shear plane. And this angle right here is your phi, the shear angle, and this angle is your alpha, and this angle is beta, that is the frictional angle. So this, if you just complete the circle, then you will find the merchant circle. So you don't have to draw circle every time you use this, you draw this figure. So we will not be drawing this here, we will be just drawing the things that we require. So now this angle will be, if you can see, this is 90°, and this right here is this angle is alpha, and you are getting beta here. So this angle which is here will be, this is 90° minus beta, so this angle will be beta minus alpha. So from this figure, it is very simple to look into, it is very simple to just see that Fs, shear force, that is force that is on the shear plane, will be R resultant cos, so what it will be, R cos beta minus alpha plus phi. So here you can calculate R, because you have this Fc and Ft, and after that you have already calculated the value of phi, and you have the value of alpha. But do you have the value, or can you calculate the value of beta from the data available here only, or do you have to use this merchant circle, merchant theory? The merchant theory is this. So we will use only if we are not able to find the values in some other or from our basic standard steps, standard geometrical equations. So you can see that we can find the beta without this merchant theory help. So to do that, just remove it from here. To do that, what you have to do, you have to remember that I have already discussed and I have already told you that the formula ft by fc is equal to tan beta minus alpha is very important, and you just have to remember it. You don't derive it, don't just take it lightly. Just remember that this formula, that is tan of beta minus alpha, is equal to ft by fc, and you can see how this derivation or equation we came to this equation by seeing the figure. In this right angle triangle ft, fc and r, this angle is beta minus alpha, how I have discussed it. So ft by fc will be tan of beta minus alpha. Simple, but you have to remember it. So from here you will be getting beta minus alpha, which we need to find the value of fc. So beta minus alpha will, from here you can just calculate it. ft by fc will be 1259 divided by 1601. So it will come out as 38.20. So this is your beta minus alpha, and we have to just add the value of shear angle, and we will be getting this fs. So fs will become I am just writing it down, 110.2.71 newtons. So this is the value of shear force, and this value you can see is we can calculate it very easily, but since I have to discuss you, I have to give all the steps. Therefore I have taken my time, so that you should also take your time to first understand it. Then if you have first understood the question properly, why this question I am doing, you have also understood, because of all the little tidbits that I am discussing in between the questions are very important, because in that you can see that there are a potential to make mistakes. So you have to be careful in each and every term, in each and every part of the discussion, and you have to just carefully listen and just be well aware of the fact that what the process is. And you have to also see for yourself what is the better way to solve a question, so that you can solve it correctly without error, and also in a fast or quick time. So we will now find our final answer, which is the tau s. So tau s will be equal to fs, which we have calculated, sine phi, which we know, bt. So in this question, if we will see if the width is given or not. So thickness is given as 5, so we will be taking that. So our final answer is coming out to be So it is coming out to be 718.74 newtons. So this is the, sorry, not newton, per mm square. So that is megapascals. So since shear strength is asked and we have taken B and T values in mm, so is the option given? So the first option is very much close to it. So our first answer will be A, 722 722 megapascal, not mm, and this is the correct answer, and this is the answer that you have to write after doing this question. And as you can see, this question has been asked in a GATE examination, and this question, you can solve this question in a variety of ways, but the way, the method I have just taught you I think that method is the method that you should use, because that is the one of the error-free methods, and in that method you don't have to remember all the cumbersome equations of Fs and all that. You can just find that by drawing merchant circle and using that. And don't use the merchant theory here, because you don't require that. And if you are using merchant theory to calculate the answer of this question, to calculate any of the values, alpha is given, but if you want to calculate beta or phi and you are directly without any confirmation that whether you can find it without it or not, you are using the merchant theory, then you will be getting wrong answer, and you can just check it for yourself. And that's it. To do this question, two main objective to discuss this question was that you remember the first of all what the question is given. It is given that perfectly plastic material is being machined. So first thing you have to see here that the material that is being machined, that is being turned, is perfectly plastic, and it might get asked in one of the GATE examination that what is the nature of the material that is machined, what assumption we take. So we take it as perfectly plastic. And next thing we learned about is in orthogonal turning, what is the value of uncut chip thickness. So it is equal to F, that is feed, and how we can calculate feed if we are given with axial feed. So axial feed is equal to Fn. We have to just divide that with the rotational speed to get the feed, and that feed we will be taking equal, we will making equal to the uncut chip thickness to calculate that value. And after that we can just find R, which is the chip thickness ratio, T by Tc, and we can use that to calculate the shear angle. And also I have discussed about this formula, which is again I am writing because this formula is having a lot of importance. So Ft, that is thrust force by cutting force, is equal to tan of beta minus alpha. So this you have to remember. You can easily calculate beta from here, and you have to also remember, or you can just see the merchant circle and just find this, that Fs shear force is equal to beta minus cos of beta minus alpha into R, that is resultant. And the resultant you can easily calculate by making the sum of square root of Ft, making the square sum of Ft and Fc and just taking the square root. So that's it. This question was very nice. You can see a lot has been answered, a lot has been learned from this question. And this question was similar to the question we discussed before, where we also learned a lot of things. So in each and every questions we are learning ton of things, and that tons of things we will be implementing, we will be remembering, so that we can make ourselves better prepared, both in our speed and both in our concepts. So next question is this question is, now we will just do a little question which is from the tolerance. So a circular shaft having diameter, the value of diameter is given as here, is manufactured by turning process. 50 micrometers thick coating of TIN is deposited on the shaft. Allowed variation in the film thickness is plus minus. So this film thickness is also having allowed variation. The minimum hole diameter to provide to just provide clearance fit is. So again, this question is of GATE exam question, and before doing this question I will be taking a little break in which I will be just drinking water, and I will be back in a minute. So just if you want to do this question, just I am giving you time of 1 minute to do this question. So what this question is asking is that you are given a circular shaft, data given with tolerance, and you are given a coating which is 50 micrometers thick. So this is thickness of the coating. So this term right here is very important, that this is the thickness of coating, and there is variation in coating, and that variation is plus minus 5 micrometers. The minimum hole diameter to just provide clearance fit is being asked, and the options are given. Now we will do our question. So first of all, if you are not watching this live, then I would just recommend to watch it live, because there you can have discussion on the get-go and you can clear a lot of things. You can also ask if you have a tip or trick for you to check or you to just confirm, and that will ultimately help you a lot if you are preparing or watching it record or archive form. So just for your benefit, watch it live. So I will be going around 2 p.m. live most of the days. So just remember that, and just make sure you are live, and to get the most of out of this lectures. So what is the solution that we have to do here is first of all, minimum hole diameter to just provide clearance fit is asked. So we have to calculate the diameter of hole. So what we have been provided with is this shaft size, and over this shaft a coating is applied, and we have to find the value of hole which provides minimum clearance. If you are asked that you have to provide clearance, then in the question there definitely involves shaft and hole. So here shaft values are given, and along with a coating value is given, and hole we have to find the minimum diameter of hole. And to just provide clearance fit, to just provide clearance fit, we have our minimum clearance, that is lower limit of shaft equal to, sorry, not equal to, let us just write it properly. We have to make this equal to 0. So lower limit of hole, sorry, here it should be written hole. So lower limit of hole should be equal to the upper limit of shaft. So upper limit of shaft means we have to find the maximum size of shaft, and after that we can just make it equal, and we will be getting minimum hole diameter. So we will write minimum hole diameter is equal to upper limit of shaft after coating. So upper limit of shaft will be, since we have this shaft, upper limit will be maximum shaft size, and we have to also add the coatings value, which is the maximum one. So maximum coating size will be 55 micrometers on both the side, because the term that I highlighted at the start of this question is thick. So this is the thickness. Therefore we have to, if we are finding the diameter of the maximum shaft size, then we will be adding the coating value thickness both the sides, because thickness works like that. So upper limit of shaft will simply come out to be 65, that is 65.01 maximum shaft size plus the coating 55 divided by 1000 into 2. So our upper limit of shaft, which will be the minimum hole diameter, it is coming out as 65.12 millimeters. So this is the minimum hole diameter which just provide the clearance fit, or we can say which is equal to the upper limit of shaft, so that when clearance or when the fit is there, it will just provide the clearance fit. So this is the question. This question was very well worded because it tested a lot of things in just a few lines, and you can see that your tolerance concept can be more better if you properly understood this question and you properly solve this question. So for better of your so for your whole better of your preparation to make your concept strongs, you just have to do this question by understanding it fully and just see what are the terms here that are given, that you have to focus the terms. Let me just show you. First, to provide just clearance fit. So if something like this is given, you know that you have to just write clearance fit, and the clearance is equal to the hole minus shaft size, and the minimum clearance here will be the lower limit of hole minus upper limit of shaft. So lower limit of hole we have to calculate, because question has asked that minimum hole diameter in mm, so that we will put equal to the upper limit of shaft, and upper limit of shaft can be calculated by finding the maximum shaft size, which is 65.01, and I have added the maximum thickness of coating, that is 55 micrometers, after adding the variation of that thickness uh, considering that. And we have just found out that this thickness we have to add two times because of the nature of thickness. That is, if we are finding the value of radius, we have to calculate add it only once, but if we are finding the value of diameter, we have to add the thickness on both the sides. So that's it for this discussion of the question. And this question, again, if you have any doubt, just be free to ask in the question. And that's it. And next we will be doing this question, which again is a question, manufacturing question, but this question is somewhat different, and this question is not requiring some heavy concepts for you to just see, but this the thing that you will be understanding by this question is that sometimes you have to keep it simple. Okay, so in this class, let's see what are the questions left before we will end this class. So this question, as you can see, five questions are left, including this question. So let's do this question and let's see how we can keep things simple and how we can answer the questions here. So a circular hole of 25 mm diameter and depth is 20 mm is machined by EDM process. The material removal rate in mm cube per minute is expressed as 4 cross 10 to the power 4 I into T raised to the power minus 1.23, where I is equal to 300 amperes. Melting point of the material is 1600 degrees Celsius. The time in minutes for machining this hole is correct up to two decimal places. We have to calculate. So I will be here just in a minute. So sorry for the inconvenience. There was some thing that I have to take care of. So we have 5 questions left for the day, and we have done some beautiful questions in which we studied a lot of things, a lot of new concepts. So in this question, it is given that, let me just again read it, that a circular hole of 25 mm diameter and depth of 20 mm is machined by EDM process. The material removal rate is expressed as this value, that is, this equation is given. Here the current is given as 300 amperes and the melting point is given as 1600 degrees Celsius. The time for machining this hole is asked, and we have to write it correct up to 2 decimal places. So we don't have to, first of all, in this equation, the where term is used, where I is in amperes and its value is 300. The melting point where is 1600 degrees Celsius, where melting point is 1600 degrees Celsius. This means that this where means that you have to write this T value and this I value as it is. You don't need to convert it into kelvins. You don't need to go that extra step. This question is keeping it simple. This question is keeping it simple. So this is the main thing that we will be learning from this question, that we should keep things simple when it is required. Not always things are complicated. So here the melting point of material is given as degree Celsius, and we have to use that only because it is given in this equation where I and T's are equal to this. So you don't need to go that extra step to convert this into Kelvin. Kelvin is not some hi-fi unit. It is just a unit, just like degree Celsius. So don't always convert to kelvins when you are seeing a degree Celsius term. So the melting point, we can first material removal rate we can calculate. The material removal rate will be equal to 4 cross 10 to the power 4 into I, that is 300 amperes, into T 1600 raised to the power minus 1.23. So it is coming out as 1374.40 mm cube per minute. Very simple. Now the machining time for this hole is asked, and EDM process is given. So since material removal rate is here, and to calculate the machining time, what we will be doing here is we will find the area of cut, and we can find the volume of cut. So to calculate the machining time, simply see the units, and after you have seen the units, area of cut will be this. Let me just erase it. Into the depth, and therefore we will get the volume of material removed divided by the material removal rate. So what we will be getting here is we will be getting the value in minutes, and that we have to find. So simply what we will be getting here is so it is coming out as 7 point. Let me just again see. So it is coming out as 7.14, and that is the thing that you have to write here. So what we calculated here is, we calculated first of all the material removal rate that is already given in the question. Then it is given that a circular hole of 25 diameter and depth itna is machined by EDM process. Therefore, we have calculated the volume of material that is removed. And after that, we have been asked the time in minutes. So we simply calculated the value that is coming out as 7.14 minute. So this is the final value, final answer to this question. And let me just tell you one more thing, one more important thing here is need to be I just need to tell you one more important thing. So let's just tell this. Just wait a second. So the thing that I wanted to just tell you, inform you here is that here you can see that somehow during my I gave this GATE examination paper in 2018, and somehow I calculated the answer. I don't know how. I think this is just a panic. I was in panic mode, or somehow I just got this question wrong due to the rough work. I calculated time 1 by t. I calculated not t, I calculated 1 by t. I somehow just made the error of doing MRR, material removal rate, and dividing by the volume. So my answer was coming out as 0.1399. So I just thought there during the examination that why the time is asked in minute if it is in points, because if it is coming in decimal, then the time should be asked in seconds, because usually what the question asks is that the minutes is there when the time is above 1 minute. But if it is below the 1 minute, then the question is asking for seconds, because that is the better unit to just write. So I had this, but I then saw that there are the thing that is also written that we have to answer it correct to 2 decimal places. So I thought that this will be the answer, but I made the mistake. I calculated 1 by t, and as you can see, the answer is asked in minutes because it is 7.14, which is easily better written in minutes this time. But if the answer is 0.1399, then the question would have asked the answer in seconds. So I think you should just notice this. If you are getting some weird answers or some answers which are not that much better to write, then just check your whole process again, because you can easily lose marks. And I lost 2 marks in this question due to this very silly mistake. So the main thing that I would like to here inform you is that, first of all, keep the things simple. Here in this question, a lot of people made this mistake, and fortunately I didn't make this mistake, that some people calculated the temperature melting point given in kelvins, but it is simply stated where T is equal to 1600 degrees Celsius. So you don't have to just calculate it in Kelvin. And some people like me just made some error which is very unique and which is very weird. So that you have to just also remember that whenever you are answering, just look for the just one of the things that you can look for is that whenever you are answering time in minutes, it should be greater than 1. If it is not greater than 1, just check out your process again. And if you are after checking again, if it is coming out to be the value that you have calculated, then it is fine, but check out for again, just to be more cautious. So we will do our next question now. In this question, it is given that Taylor's tool life equation is used to estimate the life of a batch of identical high-speed steel twist drills by drilling through holes at constant feed in 20 mm thick mild steel plates. In test 1, a drill lasted 300 holes and at 150 rpm, while in test 2, another drill lasted 200 holes at 300 rpm. The maximum number of holes that can be made by another drill from the above batch at 200 rpm is. So we have been provided with two set of values first of all, and we have to calculate the maximum number of holes that can be drilled from a 200 rpm running speed batch, and we have to find this correct up to 2 decimal places. So let's do this question. This is also one question where you can learn a lot. So Taylor's tool life equation is used to estimate. So first of all, in test 1, 300 holes, (150 rpm). Test 2, 200 holes, 300 rpm. So we know that V t raised to the power n is equal to constant. Therefore, velocity will be pi. Let's take diameter common, d n divided by, since the velocity we write it in meter per minute, so we will not divide it by minute, we will simply divide it by, because the d will be there in, so let's say that d is in meter, because no diameter of drill is given. And time, so to calculate time, what we have to do, we have to just write here that effective length drilling divided by f into n. So n is 150, and raised to power n is equal to again pi d 300. And one more thing here, it is given that since the t here is the tool's life, therefore we have to multiply 300 here also. Because this LE, that is effective length divided by Fn, is for a single time for a single hole. So from here we can calculate the value of n, and after calculating the value of n, we can simply calculate the number of holes for the 200 rpm speed. So let's do that. First we will cancel these things out. So what we are getting here is 2 raised to the power n is equal to 2 into 2 by 3 raised to the power n. So here what we can see here is that (3 raised to the power n is equal to 2. So n ln 3 is equal to ln 2. So n is equal to 0.63. So n is equal to 0.63, and now we will be calculating the value of number of holes for 200 rpm speed. So to do that, we will simply write the n here. So n for first is 150 rpm. Then inside this we will write the number of holes, which is 300, and we will write n again. Then we will write here small n, that is the exponent. It is only 0.63, not extra 0 is involved here. And speed, again rotational speed, number of holes we have to calculate, so just write holes, and rotational speed is given as 200 and again 0.63. so from here holes will be coming out as so it is coming out as holes 253.36. that is it is nearly equal to we can since it is given that we have to write correct up to 2 decimal places, so just you can write 53.36, or you can just round off it and write 254 holes. So I hope I can write this also here, just so that my video footage is not hiding it. So this is the correct answer, 254 holes. Or you can, if you want to write in decimals here, that is also a option, because of the line correct up to 2 decimal places you have to calculate 253.36. so in this question you can see that what we have used the approach, we have written the Taylor's tool life equation, that is V t to the power n is equal to constant, where t is in minute, v is in meter per minute. We have taken care of that. We have just found out that the t, we know that the t in this equation is the tool's life. So for tool's life will be the number of holes that tool is lasting, and that number of holes will be multiplied by the individual hole time to calculate the total tool time. Therefore we have made that, and we have calculated the tool life by that process, and we have find out the v, that is velocity in meter per minute. And after that, first of all we are finding the n, which is the Taylor's tool life exponent, and that is coming out as 0.63, which is correct because it is usually between usually around this value only. And after that we are just using that complete equation to calculate the number of holes if we are using the speed 200 rpm. So the correct answer is 253.36, or you can also write 254 holes. And in the GATE answer key, it is given 252 to 254 holes. So the range is there for you to answer. Now in the next question, we have been provided with the casting question. So in this casting question, it is given that for sand casting a rectangular plate with dimensions given. So this is the dimension of a rectangular plate, and a cylindrical riser has to be designed. Okay, so we have to design a cylindrical riser. The height of the riser is equal to diameter, so we will just write given. So for the riser, the height is equal to diameter. Total solidification time for casting is 2 minutes. So T solidification for casting is 2 minutes. In Chovorinov's law, for the estimation of the total solidification time, exponent is to be taken as 2. So that this line right here, this line is nothing but what we study. So this line you don't have to just focus too much. You again have to keep things simple, because Chauvinov's rule, we know, we have already studied that it is equal to, in it the solidification time is proportional to the solidification time is proportional to the V by A ratio square. So that exponent is 2. That is only thing that is provided here, nothing new this line gives us. For solidification time of 3 minutes in riser, the diameter of the riser is, so solidification time of riser now is given as 3 minutes. So diameter of riser is asked. So what we will be doing is, we don't know the solidification factor, and we can calculate solidification factor if we want to, and we can also do this in some other way. But here what we can see is, we need the diameter of riser, and for that we need to just use this solidification time equation, which is Ts riser is equal to K solidification factor into V by A. So what is the volume? If height and diameter of a cylindrical riser are equal, then it will be pi d square by 4 into d. Area will be pi d square. So what type of riser is the here? Side riser or top riser? So I think we have to take side riser only. So pi d square by 4 into 2 plus pi dh, that is pi d square, because diameter and height are equal. So it is coming out as d cube by 4 divided by d square by 2 plus d square. So this will come out as d by 4 3d by 2. So d by 6. So you can just remember, it is better to remember that whenever height and diameter of a normal cylindrical shape is equal, their V by A ratio is coming out as d by 6 or r by 3. So just remember that, and you can be saving this much of time of calculating V by A there. I have discussed this before, and I have already informed you about that. You should be remembering the d by 6 things, and if diameter and height are equal. So just remember this and save a lot of time. It can save a lot of time, as you can see here. And we need to just find, this value is equal to 3 minutes, it is given, and we have to just find out K here, and after that we can calculate the D. So to calculate K, we have to go to the casting solidification time, and let's just go there. So TS casting is given as 2 minutes, and that 2 minute is K V by A. So volume of that casting will be simply 80 cross 120 cross 20, and it will be square, and the total surface area will be 2 times length plus breadth plus LB plus BH plus HL. So let me just calculate it, and 2 will be equal to K. Since we are writing time here in minutes, we will be also writing time in minutes only, not converting it, if we use that K value to calculate the diameter of the riser. So this is a lengthy calculation, but there are a lot of values involved, so this is lengthy. So just make sure that you are doing this properly in your calculator, or else you can easily make silly mistakes. So it is coming out as 0.04. Now I will be calculating the value of diameter at the top, so it will be 3 minute is equal to 0.04 d by 6 square. So the value is coming out as 51.96 mm. So this is the value that is coming out, and you can just have your answer. In the official gate key, it is given that answer is given as 42 to 52. So we are just under that, 51.96. We will just see one more time if we can just find a value which is between between the range, or is this the correct answer. So what we will be doing is we will be taking k as more exactly. So for that we will be converting the minute into seconds. Two point 408 is the value if we are taking the time in seconds and calculating k solidification factor according to that. So answer is now coming out as 51.87, which is again very much just there with the under the range. So the correct answer will be 51.96, and the range that is given is 42. I don't know how 42 is given to 52. So you can see, don't calculate in such a manner, calculate it precisely, because if your answer somehow came out to be, if you are doing some approximation 52.0001, even if that, then it will be wrong. So just take care that you are using not some approximation during your calculation. Use at least up to 4 or 3 decimal points to solve your questions. And this is the final answer. And as you can see, again, this question is very well made. And in this question, you can calculate, you have to calculate 2 or 3 things, and there are calculations that you can make mistakes in. So main objective to do this question is again to keep things simple, have to do the calculation in a way which is more tidy. This is not a tidy way, but you can calculate it more step by step than this. Since the space was very limited, so therefore I solved this in this manner. But you, for this question, when you are doing in your rough copy, just make sure you are following the steps and you are just writing it like that. So again, I think this is the same question. So this question was is repeated here. So again, let me just write the answer. 51.96. These are the questions. These questions are very latest questions. So we are just doing the questions which are recently asked. Recently, the GATE in the GATE we are being asked some of the quality questions, and some of the questions are very lengthy. So you have to be very well prepared and very well clear about your approach, because you have to solve this lengthy questions, and this can easily take a lot of time. So don't just lose heart if you are finding this question lengthy and you are taking 2, 3 or 4 minutes solve the questions, or even 5, because ultimately this question is long. So you have to first understand it properly and do it correctly. So it is better to take time, not too much time, but still you can take time to solve questions correctly, because at the end of the day, if you are doing questions correctly in a okay time, then it is good to do the questions wrongly in quick way, because you can lose easy marks if you are not taking the questions properly. So now this is the question, and this is our final question before we end the class. In this question, we are given orthogonal cutting operation, and uncut chip thickness is being provided here, and cutting speed is given. So cutting chip thickness, uncut chip thickness is given, cutting speed is given, and rake angle is given, width of cut is given. It is observed that chip thickness is this much, and cutting force and thrust force is also given. Orthogonal cutting, again very important, you have to notice this. Ratio of friction energy to total energy is asked. So for friction energy by total energy, what we will be doing to calculate the radius, we can also calculate the ratio of power here. So it will be equal to F into V cutting, that is cutting velocity, that is the velocity of not cutting velocity, chip velocity. VC is chip velocity. So chip velocity is the velocity of chip with respect to the tool, that is where the friction is acting on that surface, and total power will be FC, that is cutting force into the cutting velocity. So again I will be writing this properly now. Let us use red ink. So F into VC, that is chip velocity, divided by FC, cutting force, into the V, that is V is your cutting velocity. So just for your information, VC by V is nothing but T by TC, that is the chip thickness ratio. Chip thickness ratio R is equal to T by TC less than 1, because chip thickness is uncut chip thickness is less than the chip thickness, cut chip thickness, and it is equal to velocity of chip divided by velocity of cutting velocity. And you can see here that the cutting velocity is greater than the chip velocity. So this is the term that you have to remember. And also the length of chip that is cut is less than the length of chip that is not cut, uncut. So it can be also written equal to this. So this is the things that you have to remember. And here if we know one of the terms, then we can, one of the ratios, we can just put it equal to, we can just write it as other ratio, because they are equal, these are equal. So since T and TC are given in the question, therefore we have just taken this ratio as equal to this. So we have to just find, here we have this, we have this, we have this, we have to just find the frictional force. And to calculate frictional force, what we need here is we need the beta angle, that is the frictional angle. So I am not drawing merchant circle now, because I have discussed it in this class only. Tan of beta minus alpha is equal to Ft by Fc. So from here, beta minus alpha is coming out as Ft, thrust force is 25 and the other force, cutting force, is 60. So tan inverse, we are getting this as 22.62. Let us just erase it. 22.62 degrees. So beta will be this much plus alpha. So it is 37.62 degrees. And we know that F will be equal to, since this is the merchant circle, let me see if we have drawn here. So we have drawn here, and just see just see here. Here the F, that is the frictional force, will be equal to R sine beta. So R sine beta will be equal to your F here, and therefore, because this is the right angle triangle, we will be writing F equal to R, that is the resultant force, sine of beta, and we can calculate R by this formula, which is Ft square plus Fc square. So what will be the answer here? It is coming out as 65, and sine beta will be, we are getting 39.67 newtons for our frictional force. And this frictional force, we will be just using it to calculate our ratio. So the answer that is coming out, that is the ratio. We are just ratio of energies asked, that is F into Vc divided by Fc into V. It is coming out as 0.44. So this is the correct answer, because we don't have to write this answer in percentage. So the correct answer is 0.44, and this is the, again you can see we have taken the ratios of power, because energy power ratio both will come out as same, and we have taken Vc by V from our equation of the ratio equal to T by Tc, because the chip thickness ratio are given by these three formulas written at the top, and we can use either of them or use them interchangeably. And we have calculated first of all frictional angle by this formula that I have already told you a lot times that you have to read, that is tan beta minus alpha is equal to Ft by Fc. Ft and Fc is given, alpha is given, therefore we calculated beta, and after that we have calculated the frictional force by R sine beta formula, and R we have find the resultant by just putting the Ft square plus Fc square sum, it is under root, and we have calculated, and it came out to be very conveniently 65 newtons. And then we have calculated F, that calculated F we have used in our equation that is written at the first after the solution, and this equation we are getting our final answer as 0.44. So what you need to remember here is that first of all the R thing, that you can use interchangeably these three equations, these three ratios. Tan beta minus alpha is equal to Ft by Fc, and also F is equal to R sine beta. We have used this after seeing this merchant circle that you can see in the yellow or golden circle. Here this merchant circle, you can find the frictional force simply by the geometry. You don't need to remember something extra. So that's it for the questions today, and that's it for the discussion for today. And I hope you have enjoyed the class, and I hope you have found this class helpful. So if you think this class is all these things, and the discussions I did in this class is making you more confident and making you more better prepared, then just hit the like button and subscribe to this channel and hit the bell icon for notification, because we will be going live, or I will be going live at around 2 p.m. most of the day. So you will be getting a notification when my class will be going before some time, so you can be well prepared to attend the class, or you can properly manage your schedule according to it, and just come to my live class so that we can interact, we can just discuss the GATE things, and we can discuss tips and tricks. You can clear some doubts, you can ask for some approach to study and all this. And don't forget to use this code, that is ABHIMI, to get 10% off. When you are using this code, you are getting a flat discount of 10% off over the discount that you will be getting from Unacademy. This is some extra discount you will be getting. So use this special code, and you can share the special code with your friends and with other students also, because multiple account can use the same code. And subscribe to Unacademy, just start giving test series and learn from your mistakes. prepare in a manner that you are satisfied at the end of your preparation, and you can just give GATE exam with full confidence. And just be calm, just take GATE as just an examination, because it is just an examination, and just enjoy preparation and just enjoy all the other things that you do. Just prepare a well balance, don't take too much stress, just be calm and prepare well. So that's it for today's class. Stay safe, take care, and so that's it.